The sun, the heart of the cosmic garden. Before there were planets, moons, oceans, or even poetry, there was light. About 4.6 billion years ago, deep in a quiet corner of the Milky Way galaxy, a cold, dark cloud of gas and dust floated undisturbed, waiting for destiny to tap it on the shoulder. Then came a ripple, a nudge. Perhaps the gentle shock wave of a nearby exploding star, what scientists call a supernova, swept through this sleepy cloud. That ripple started it all. Gravity, like the universe's invisible puppeteer, began to pull the gas and dust inward, tighter and tighter, into a spinning, glowing ball. This ball would become the sun, our sun, a furnace of fusion, a cauldron of hydrogen dreams. As more and more material collapsed inward, the pressure and temperature at the core rose to unimaginable levels. Eventually, at around 15 million degrees Celsius, no, not a typo, atoms of hydrogen began to fuse together to create helium, and just like that, nuclear fusion was born. Light burst forth. The sun ignited. Our star had awoken. The sun may look like a big golden yolk in the sky, but don't be fooled. This is no peaceful breakfast treat. It's a raging sphere of plasma 1.4 million kilometers across. That's 109 Earths side by side, and so heavy it accounts for more than 99.8% of all the mass in the solar system. The remaining 0.2%, that's everything else. Jupiter, Saturn, Earth, coffee, kittens, everything. At its core, hydrogen atoms are constantly colliding with such force that they fuse into helium, releasing energy in the form of gamma rays. Now, this energy takes thousands, yes, thousands of years to travel from the core to the surface. From there, it takes just 8 minutes and 20 seconds to reach your face, warm your cheeks, and make you squint on a summer day. That little sunbeam. It was born before human civilization even knew how to write. As it burns, the sun balances two mighty forces, the inward pull of gravity and the outward push of fusion. These keep the sun in a delicate blazing dance, neither collapsing nor exploding, a harmony forged in fire. Chemically speaking, the sun is mostly hydrogen, about 74%, and helium, about 24%, with traces of oxygen, carbon, neon, nitrogen, magnesium, iron, and silicon. Basically, the periodic tables party crowd. These elements swirl within different zones: the core where fusion happens, the radiative zone where energy slowly drifts outward, and the convective zone where hot plasma churns like a boiling soup. Above all, this is the photosphere, the part we see with our eyes, a blazing surface at around 5,500 degrees Celsius. But the real cosmic drama lies beyond, in the outer layers, the chromosphere and the corona. The corona is so bizarrely hot, millions of degrees, that it still confuses scientists. Like, why is the outer atmosphere hotter than the surface? The sun is literally the original drama queen. It also has moods, sunspots, flares, solar storms. These are signs of the sun's magnetic tantrums. Giant loops of plasma called prominences dance across its surface. Sometimes the sun flings out charged particles in massive eruptions called coronal mass ejections. These can mess with satellites, GPS, even power grids on Earth. But they also give us auroras, the shimmering curtains of light near the poles, beauty and chaos hand in hand. And beyond science, there's an eerie beauty to it all. The hypnotic swirl of plasma, the rhythmic pulsing of solar waves, the constant churning. It's like a star breathing. If you could somehow stand on a planet orbiting a star just like it, you'd watch as that distant orb painted your skies in amber and fired day after day for eons. Our ancient ancestors looked up at the sun and gave it names, myths, and meaning. It was Ra, the Egyptian god, sailing his golden bark across the sky. It was Helios, Apollo, Tanatia, Amaterasu. It was the bringer of crops, warmth, time itself. People built entire civilizations around its rhythms: sunrise, noon, solstice, eclipse. Stonehenge bows to it. So does every sunflower. Calendars were shaped by it. Rituals danced for it. Harvests waited on its return. For millennia we looked up, not knowing what it was, only that without it we would perish. And yet, as poetic as our love affair is, the sun has never noticed. It's too busy burning its hydrogen in blissful indifference. Now lean in closer, dear dreamer, because here comes the twist. Our beloved sun has a lifespan. It's not eternal. Like all stars, it was born. It shines. And one day, it will die. We are currently in the main sequence phase of the sun's life, the golden middle age. It's been here for about 4.6 billion years and will stay comfy like this for another 5 billion. But when the hydrogen runs low in the core, the sun will swell into a red giant, so big it might engulf Mercury, Venus, and yes, Earth. But don't panic, we've got billions of years. Time enough for 1,000 civilizations to rise and fall, for humanity to figure out how to vacation on Titan or build a condo on Mars. Once the red giant phase is done, the sun will shrug off its outer layers in a luminous farewell called a planetary nebula. What remains will be a white dwarf, a glowing ember, no longer fusing, just cooling over the eons until it fades into a black dwarf, a cosmic ghost. And then darkness, a quiet that echoes across light years, but not a sad ending, a return. The material cast off by the sun will drift back into space, enriching clouds of gas and dust that may one day form new stars, new planets, maybe even new dreamers. But right now, it's here, alive, radiant, breathing light into our days. Every leaf that photosynthesizes, every rainbow, every tan line, every firefly's glow, it all traces back to that ball of plasma 150 million kilometers away. It's the clock of life, the cosmic heartbeat, our eternal lighthouse in the sky. And yet it asks for nothing, no praise, no recognition, just the infinite satisfaction of fusion and light. So next time you squint into the sky and complain it's too bright, remember you're looking at a star. Your star, a 4.6 billion-year-old fusion-powered lighthouse, keeping you warm, fed, and just a little sunburned. And so we drift off, snuggled in stardust, knowing that the sun is still up there, buzzing, blazing, burning with purpose. Not for us, not really. But we're lucky enough to bask in it, to orbit around its fire like a devoted planetary waltz. Round and round, forever in awe. Good night, soul. Mercury, the silver whisperer of the sun. Before the day has even fully stretched its golden arms across Earth's sky, Mercury has already danced its way around the sun like a mischievous child chasing fireflies. The smallest planet in our solar system and the closest to our radiant star, Mercury is a quiet, glimmering ghost, forever caught in a cosmic game of tag with the sun. It doesn't boast swirling storms or icy rings. It doesn't hold oceans or dazzling clouds, but oh, dear dreamer, it has its own kind of magic, a mysterious scarred silence, a beauty forged in fire and shadow. Roughly 4.5 billion years ago, Mercury was born from the same swirling disk of dust and gas that birthed the rest of our solar system. But something curious happened. Either it formed under strange conditions, or it was battered early on by colossal impacts, because Mercury is different. It's tiny, just a bit bigger than our moon, but it carries a secret. A massive, iron-rich core lies beneath its rocky skin, making up over 60% of the planet's entire mass. That's more core than crust. It's as if Mercury was meant to be bigger, but lost its outer layers in some ancient cosmic accident. Or perhaps it was always meant to be dense, gravity's little heavyweight in a featherweight body. Despite its fiery location, Mercury is not the hottest planet. That honor goes to Venus, queen of greenhouse gases. But Mercury experiences the most dramatic temperature swings. During the day, the surface can reach 430 degrees Celsius, 806 degrees Fahrenheit, hot enough to melt lead. At night, it plummets to minus 80 degrees Celsius, or minus 290 degrees Fahrenheit. It's like a cosmic sauna that turns into a deep freezer as soon as the lights go out. Look closer at Mercury's surface, dear dreamer, and you'll see it wears the past like a proud, cratered cloak. Its skin is scarred with the memories of billions of years of impacts. Massive craters, ridges, and ancient lava plains stretch across its face like wrinkles on an ageless storyteller. One of its most dramatic features is the Caloris Basin, a colossal impact crater over 1,500 kilometers wide. When whatever cosmic object slammed into Mercury to form it, the shock waves rippled through the entire planet, creating strange, hilly terrain on the opposite side. A planetary concussion frozen in time. Mercury also has massive cliffs, some stretching for hundreds of kilometers and soaring up to a kilometer high, caused by the planet shrinking as it cooled. Imagine that, a planet getting smaller as it grows older, wrinkling like fruit left in the cold, a rocky world curling into itself like a secret. Time moves differently on Mercury. It's a planet with a peculiar rhythm. It takes just 88 Earth days to complete one orbit around the Sun, zipping through space like it's late for a cosmic appointment. But its rotation is much slower. One day on Mercury, from one sunrise to the next, lasts about 176 Earth days. So if you stood on the surface wearing a very good spacesuit, mind you, you'd see the sun rise slowly, stop and hover strangely in the sky, move back toward the rising horizon, stop again, and finally restart its journey toward the setting horizon, and eventually set in the opposite direction from where it rose. A surreal ballet of light and shadow. Day and night aren't just times, they are events. Despite being so close to the Sun, Mercury doesn't have much of an atmosphere to speak of. No fluffy clouds or gusty winds, just a tenuous exosphere made of atoms blasted off the surface by solar radiation and micrometeoroids. It's more a halo of scattered whispers than a protective cloak. Still, it does have a magnetic field, faint but fascinating. That magnetic field, plus its dense core, suggests Mercury is still partially molten inside, still humming with energy after billions of years, a tiny iron heart still beating beneath the silence. We've only truly met Mercury thanks to two space missions, Mariner 10 in the 1970s and Messenger in the early 2000s. The latter orbited Mercury, mapped its surface, and gave us breathtaking close-up views of this elusive world. The name wasn't just clever. Messenger is also what the planet was named after. Mercury, the Roman god of messages, speed and travel. Fitting, isn't it? A little world that whispers ancient secrets into the sun's ear as it loops and loops through space. No moons, no rings, no noise. Mercury is utterly alone, and yet it remains radiant. It glows faintly in twilight skies just after sunset or before sunrise, a silvery gem known as the morning star or evening star. Always near the sun, always elusive, always hard to catch. It doesn't shout for attention. It glimmers quietly on the edge of your vision. In its stillness, it reminds us not everything needs grandeur to matter. Not every story has to roar to be worth listening to. Some are whispered, some are written in craters and silence. So sleep now, dear dreamer, with Mercury close to your heart, a shy, silvery traveler with a core of iron and a history written in fire. Let its quiet strength and endurance guide you through the night. Good night, dear dreamer. Venus, the veiled queen of the skies. We drift through stardust and golden haze toward the second planet from the sun. a world so bright it can outshine the stars. So beautiful it was named for the Roman goddess of love. But don't let her soft glow fool you. Venus is not a gentle goddess. She is radiant, yes, but beneath her blushing veil lies a fierce volcanic heart, wrapped in storms, cloaked in secrets. She is Earth's twin by size and gravity, but not by temperament. Venus is Earth's dangerous sister, wrapped in pearls of sulfur and fire. If you've ever looked up at dawn or dusk and noticed a bright light near the horizon, brighter than any star, you've likely seen Venus. It's the third brightest object in our sky after the sun and moon. That glowing orb has been inspiring poets, lovers, and daydreamers for millennia. The ancient Babylonians tracked her as Ishtar. The Mayans followed her every move. The Greeks and Romans gave her beauty, myth, and mystery. Sailors once used her light to guide their way. Now astronomers watch her carefully, searching for the past and perhaps whispers of life. But for all her shimmer, Venus doesn't let us see her true face easily. Her atmosphere is a thick, choking cloak of carbon dioxide and sulfuric acid clouds. No telescope can pierce it. Only radar and brave probes have dared to peer beneath. Imagine stepping onto the surface of Venus. Except please don't. The temperature is over 460 degrees Celsius, 860 degrees Fahrenheit. Hotter than Mercury, even though it's farther from the sun. Why? Because of the atmosphere. Venus is the cautionary tale of the solar system, a masterclass in the greenhouse effect. Its thick carbon dioxide atmosphere traps heat so effectively that not even nightfall can cool her down. It's the same temperature, hellish, no matter where or when you stand. Above you, winds whip through the sky at over 350 kilometers per hour. Clouds of sulfuric acid swirl endlessly in a perpetual hurricane. The pressure at the surface is 92 times that of Earth's, like being crushed under the weight of a kilometer of ocean. And yet, she is stunning. The sky glows orange, the horizon curves around you like a dream. Volcanic plains stretch endlessly in every direction, scarred with rivers of ancient lava and crowned with vast domes and mountains. Venus may not be friendly, but oh, she is magnificent. Venus and Earth are nearly the same size. They're made of similar materials. They may have even started out as twins, a pair of planets, forming side by side, born from the same cloud of gas and dust. But somehow their destinies forked. Earth grew oceans, forests, oxygen, whales, and Einstein. Venus chose a different path. It may have once had water, perhaps even lakes, shallow seas, or clouds that gently wept rain. But if so, they're gone now. The sun's heat and the runaway greenhouse effect stripped it bare, baked it dry, and transformed it into a planet-sized furnace. Still, scientists dream. Could Venus have hosted life billions of years ago? Could microbes once have floated in her clouds? Could strange chemical signatures today hint at their ghostly echoes? Venus never answers. She keeps her secrets beneath her clouded veil, the eternal mystery wrapped in sulfur. Volcanoes everywhere. Venus has more volcanoes than any other planet in the solar system, possibly over 1,600. Most are extinct, but some might still be sleeping or simmering or quietly erupting under the surface, veiled from our instruments. There are vast lava plains, towering shield volcanoes, and pancake domes that look like someone laid down molten syrup and let it cool. The surface is relatively young geologically speaking, suggesting Venus may periodically resurface itself, burying its past beneath waves of molten stone. Unlike Earth, Venus doesn't seem to have tectonic plates, But she does quake. She rumbles. Her crust may ripple and buckle in slow, graceful agony. Even in silence, she speaks. Only a few missions have dared to touch Venus, and they didn't last long. The Soviet Veneer probes in the 1970s and 80s were the first and only to send back photos from her surface. They melted within minutes. But what photos they captured! Yellow rocks beneath a golden sky, cracked plains of ancient lava, a horizon blurred by heat and pressure. Later missions like NASA's Melin mapped her with radar, revealing her volcanic scars and mountainous ridges. And more missions are coming. Scientists haven't given up on Venus. She still tempts us, not because we want to live there, no thank you acid rain, but because she holds answers. Answers to climate, planetary evolution, geology, and even just maybe the boundary between life and lifelessness. And always, always, she remains the morning star, the evening star, the first light in the dark, the last light before dawn. So rest now, dear dreamer. Let Venus cradle you in her golden glow, fierce, ancient, and divine. She burns too hot to hold, but her beauty lingers in your imagination like a kiss from a goddess long vanished into the clouds. Earth, the luminous cradle of life. Now, instead of soaring away into the cosmic dark, we pause and turn our gaze inward, back to the familiar, the miraculous, the only place in the known universe that sings with birdsong, dances with tides, and tastes like strawberries. Earth, the third rock from the sun, our home. So easily taken for granted, so often overlooked, and yet it is the most extraordinary world we know. It doesn't shimmer like Venus or brood like Mars, but it breathes, it blooms, it holds life in a delicate embrace no other planet dares to match. Come closer now, dear dreamer. Let's fall in love with Earth all over again. From space, Earth is breathtaking, a sapphire sphere wrapped in clouds, oceans that stretch like endless mirrors, continents like ancient puzzle pieces drifting slowly over the millennia. Storms swirl, ice caps glint, sunlight plays upon its atmosphere in dazzling auroras. It glows, and unlike any other planet, it is alive. Not just geologically, though, yes, tectonic plates shift, volcanoes erupt, and continents move. But biologically, ecologically, emotionally, every inch of this planet pulses with life. From the deepest ocean trench to the highest alpine meadow, something is breathing, crawling, flying, growing. Water flows freely here, something other planets only whisper about. Over 70% of Earth's surface is ocean, a vast cradle of life and memory. Rivers cut valleys, rain nurtures forests, snow kisses mountaintops, water is Earth's love language, and fire too. At the planet's core, a molten heart churns. It powers magnetic fields that shield us from solar radiation, creates new crust, and occasionally bubbles to the surface in fiery fountains. Earth is a world of balance, fire and water, ice and heat, calm and chaos, and somehow, miraculously, life flourishes in between. Earth's atmosphere is a perfect blend for life. About 78% nitrogen, 21% oxygen, and a smattering of other gases. It's thick enough to keep us warm, thin enough to keep us comfortable, and just right for butterflies to flutter and lungs to fill. It protects us from deadly radiation. It cradles sound. It lets us hear laughter, music, and thunder. No other planet we know has an atmosphere like this. Mars's is too thin. Venus's is too toxic. Earth's is just hospitable, gentle, kind, and its magnetic field, a quiet hero generated by that molten core. It deflects the solar wind, preserving our atmosphere and giving us glowing auroras near the poles, ribbons of green and violet that dance in silence, a light show for the soul. Look at Earth's surface, dear dreamer. It's not still. It breathes. Continents drift on tectonic plates, rearranging themselves slowly over millions of years. Mountains rise, oceans shift, islands appear, valleys deepen. These movements bring earthquakes and eruptions, but also diversity. The shifting crust recycles carbon, stabilizes climate, and builds the landscape in which life adapts, thrives, and evolves. And Earth has a moon, one single beautiful companion that stabilizes our tilt, gives us tides, and lights up our nights with gentle silver. A satellite so large and close it has shaped the rhythms of life for billions of years. Even our days aren't static. Earth spins on its axis every 24 hours, giving us day and night, and orbits the Sun every 365.25 days, gifting us seasons. A perfect poetic balance between movement and stability. Nowhere else have we found a planet that not only supports life but nurtures it to this extent. Forests that stretch for thousands of kilometers, coral reefs more intricate than any painting, birds that migrate with magnetic fields, insects that pollinate flowers with dance and dust. And then there's us, Homo sapiens, curious, restless, fragile, and astonishing. From this planet came Einstein's theories and Da Vinci's sketches, the Parthenon and the pyramids, music, mathematics, myths, and microwave popcorn. Every story you've ever loved, every book ever written, every whisper and every tear. All of it. Earthborn. We are stardust, yes, but Earth is our storyteller. She gave us brains to question and hearts to wonder. We learn to speak, to dream, to reach for the stars, all while standing in her soil. We search the skies for other habitable worlds, and rightly so. But so far, Earth is the only one that knows us, that houses us, that loves us back. We live in forests and cities, deserts and ice sheets, mountain tops and deep valleys. We've adapted to nearly every corner of this planet. But we also owe it care, tenderness, gratitude. The Earth is not eternal. Its climate can change. Its resources are not infinite. And though it has survived asteroid strikes, supervolcanoes, and mass extinctions, it now waits to see how we treat it in return. It deserves more than just survival. It deserves celebration. So tonight, dear dreamer, before you drift off to explore strange worlds, take a moment to cherish the one beneath your feet, the one that gave you sunsets, music, cocoa beans, and butterflies. Good night, dear dreamer, and thank you for everything. The moon, the silver mirror of our sky. Now we're heading to the place we've always watched, from our windows, our beaches, our beds. The one who pulls at oceans and hearts alike. The one who has never left us. The moon, our only natural satellite. A steady companion. A quiet force that has shaped Earth's destiny from the very beginning. So lie back, dear dreamer. Let the moonlight fall softly across your thoughts. Her story is older than ours, and still being written. It began with chaos over 4.5 billion years ago. Not long after Earth itself was formed, a massive object the size of Mars called Theia collided with our young planet. The impact was unimaginably violent. Oceans of magma, clouds of debris. Earth staggered. But from this devastation, something beautiful emerged. Bits of Earth and Theia were flung into space, circling our battered world in a glowing molten halo. Over time, gravity gathered these fragments into a sphere. It cooled, solidified, and began to orbit. Thus, the moon was born, not captured, not found, but forged in the same fire that shaped our home. She is Earth's child and sister, and she has never strayed far. The moon is small, just over a quarter of Earth's diameter. Her surface is made mostly of silicate rock covered in dust and powdered stone known as regolith. There are no seas, no rivers, no air, and yet she's breathtaking. Dark plains called Maria, Latin for seas, stretch across her face. Ancient lava flows that hardened long ago. Craters of all sizes pock her skin, scars of billions of years of cosmic collisions. Mountains rise, valleys sink, and beneath it all lies a small iron core, a ghost of the molten past. No atmosphere means no sound, no weather, no erosion. The moon remembers everything, every mark, every impact. She holds the memory of a solar system still growing up. Despite her silence, the moon moves Earth every day. Her gravity tugs at our oceans, pulling them into bulges that we call tides. As Earth rotates, these bulges shift, giving us high tide and low tide twice a day, every day. A lunar rhythm, soft and ancient. The sun joins in too, pulling with its own force. When the sun and moon align, we get spring tides, higher highs, lower lows. When they're at right angles, we get neap tides, milder tides, calmer seas. But it's not just the ocean she stirs. Studies suggest the moon can affect our sleep, especially during the new moon, when the sky is dark and the moon hides her face, or during the full moon when she illuminates the entire sky like a giant light bulb. Some people report restless nights, strange dreams, or heightened emotions. Scientists debate the cause. Circadian rhythms, gravitational shifts, ancient instincts. No one knows for sure, but the moon has always touched more than just water. She touches our moods, our minds, our myths. From Earth, we see the moon wax and wane, cycling through phases every 29.5 days. The lunar month, new moon, invisible, a quiet beginning. Waxing crescent as silver sliver grows, first quarter, half-lit, half-shadowed, balanced, waxing gibbous nearly full, nearly there, full moon bright and bold whole, waning gibbous fading slowly, last quarter half again, but waning now, waning crescent, a final whisper before she disappears. She never changes shape, just how we see her. The moon is always full, it's the sun's light, and our perspective that creates the dance of shadows. These phases have guided calendars, harvests, celebrations, and rituals across cultures for millennia. They are the moon's poetry, read in arcs and curves. Sometimes the moon and sun align perfectly with Earth, and magic happens. A solar eclipse occurs when the moon passes directly between Earth and the sun, casting a shadow and darkening day into eerie twilight. Birds hush, temperatures drop, and crowds gaze up, breathless. A lunar eclipse happens when Earth casts her shadow onto the moon, turning it a deep, rusted red, the blood moon. These occur during full moons and can last for hours, painting the sky with ancient drama. Eclipses are rare, precise, and fleeting. They remind us that even cosmic bodies cast shadows and even darkness can be beautiful. On July 20th, 1969, humans did the unimaginable. Apollo 11 landed on the moon and astronaut Neil Armstrong stepped onto her dusty surface. One small step for man, one giant leap for mankind. It was a moment that stitched together science, courage, and dreams. For the first time, Earth's child touched the face of her parent. Since then, 12 people have walked on the moon. They've left footprints that may last for millions of years. They brought back rocks, stories, and the humbling knowledge that our pale blue dot is fragile and beautiful. Today, we prepare to return. New missions, new dreams. The moon is not done with us yet. The moon has watched over every human life that's ever existed. She has seen lovers whisper, wolves howl, poets sigh, and tides roll in. She's been worshipped, studied, feared, and longed for. She has shaped our calendars, our language, our lullabies. Her pull is more than gravitational. It is emotional, existential, and she is still watching. Always the same face turned toward us, tidily locked in perfect devotion, a cosmic constant, a quiet companion. So rest now, dear dreamer. Let the moonlight wash over you. Let her phases guide your breath. Let her story remind you we are never truly alone in the dark. There is always light, always rhythm, always a silver smile in the sky. Mars, the rust-cold dream of distant tomorrows, now we cross a quiet gulf of space past our silver guardian and into the cold, rust-tinted arms of Mars, a world that has fascinated us since the first human eyes looked skyward, a tiny red dot in the night sky, drifting silently among the stars. To the ancients, it was the god of war. To scientists, it is a puzzle wrapped in dust. To dreamers like us, it is possibility. It is longing. It is the planet that whispers, maybe one day. So come now, dear dreamer, let us explore this crimson wanderer together. Mars is the fourth planet from the Sun, just a bit over half the size of Earth, with a diameter of about 6,800 kilometers. It's a rocky world, dry and cold, coated in iron oxide. Yes, rust, which gives it that unmistakable reddish hue, like a planet built from forgotten memories and powdered sunsets. The Martian sky, in contrast, isn't blue. It's tinted, a soft butterscotch or peach during the day, and turns blue at sunset. An emotional reversal of Earth's palette. It's as if Mars wanted to keep the skies poetic, just backwards. Its days are only a little longer than ours, 24 hours and 39 minutes. And it has seasons too, thanks to its tilted axis. But everything is colder. Even in the height of summer near the equator, temperatures rarely rise above freezing, but the temperature on Mars can be as high as 70 degrees Fahrenheit, 20 degrees Celsius, or as low as about minus 225 degrees Fahrenheit, minus 153 degrees Celsius. Mars is Earth-like in some ways, just lonelier. Mars is a land of epic terrain, towering mountains, jagged cliffs, endless valleys, frozen dunes, and whispering plains. Let's start with Olympus Mons, the largest volcano in the solar system. Nearly 22 kilometers high and 600 kilometers wide, it's 3 times taller than Mount Everest and could cover the entire state of New Mexico. Imagine a mountain so massive it curves with the planet. Then there's Val Marineris, a canyon system so vast it would stretch across the United States. Up to 7 kilometers deep and 4,000 kilometers long, it yawns like a scar carved by ancient forces, mysterious and grand. Mars is a frozen storyteller, its surface inked with tales of cosmic violence, flowing lava, and long-lost water. Some craters are billions of years old, others formed in more recent ages. The surface is a frozen library of time, its pages turned by meteor strikes and dust storms. Once Mars had water, not just frost and ice, rivers, lakes, maybe even oceans. Today, dry riverbeds trace winding paths across the terrain like veins in stone. Satellite images show ancient deltas, floodplains, and channels carved by flowing water. Polar ice caps made of frozen carbon dioxide, and water grow and shrink with the seasons. But where did the water go? Mars lost most of its atmosphere long ago, perhaps due to solar wind stripping it away when its magnetic field collapsed. Without that blanket of protection, The water evaporated or froze, leaving only traces behind a lost paradise, a thirst never quenched. And yet hope lingers beneath the surface. Pockets of briny water might still exist. In 2018, radar readings suggested the presence of a subsurface lake beneath the southern polar ice cap. Could life be hiding there in secret, microbial and patient? Mars doesn't speak loudly, dear dreamer, but if we listen closely, it may whisper back. Mars has never been truly alone. For decades we've been sending robotic visitors, curious, tireless explorers who never sleep, never breathe, never blink. The Viking landers, the Spirit and Opportunity rovers, the dusty, determined Curiosity, the sky crane miracle that delivered Perseverance, and now even a tiny helicopter named Ingenuity has flown in its skies, a first for another planet. These missions have sniffed the soil, tasted the air, drilled into the rocks. They've looked for signs of life, ancient or present, and studied the geology, the atmosphere, the weather. They found methane in mysterious plumes and organic molecules buried in rock. All of it pointing to one fundamental question. Could Mars ever have supported life? And can it do so again? The answer may come not from machines, but from people. Mars is more than a planet. It is a promise, a destination, a mirror. If Earth is our cradle, Mars may be our first true step beyond. Scientists and engineers dream of habitats on its surface, growing food in sealed greenhouses, harvesting water from underground ice. Rockets have already carried supplies, tests, dreams. Human footsteps may follow. It won't be easy. The cold, the radiation, the isolation. Mars is not a forgiving place, but neither is it impossible. And just imagine, dear dreamer, waking up under a salmon sky, 2 tiny moons drifting overhead, watching the sun rise dimly over dusty hills, planting the first seeds in Martian soil, writing a new chapter in the human story, one redstone at a time. Mars has 2 moons, Phobos and Deimos, named after fear and terror. But don't be scared, they're no bigger than cities, misshapen, rocky, and full of mystery. They race across the sky like loyal shadows, and on the ground, the planet hums. Not literally, it has no strong seismic activity, but figuratively. Its winds whistle through canyons, its dust devils dance across plains. Its silence sings in frequencies only dreamers can hear. Even now Mars is shaping us, our science, our stories, our sense of wonder. So close your eyes, dear dreamer. Let Mars cradle you in its rust-red arms. Listen to the echoes of ancient rivers and the soft buzz of rovers still rolling. One day you may walk there. For now, just dream. Jupiter, the giant who guards the skies. Now we drift beyond the warmth of the inner planets and into the realm of giants where sunlight grows faint and shadows stretch long across the deep. There, looming like a myth, is Jupiter. He doesn't just orbit the sun, he dominates it. A king among planets, a colossus carved from gas and gravity. A world so vast it could swallow over 1,300 Earths and still have room for dessert. But behind that grandeur lies mystery, majesty, and a gentle strength that's protected our tiny blue world from many a cosmic threat. So float beside me now, dear dreamer, and let us greet Jupiter, the stormy guardian of our solar system. Jupiter is the 5th planet from the Sun and by far the largest. Its diameter is about 143,000 kilometers, 11 times wider than Earth. But it's not just size that makes it remarkable, it's what it's made of. Jupiter is a gas giant, a swirling ball of hydrogen and helium, more like a star than a planet. It has no solid surface to stand on. If you fell into it, not recommended, but dramatic. You'd sink through thousands of kilometers of atmosphere, crushed and cooked by pressure and heat, until you were nothing more than stardust once again. Its outer layers are clouds colored in streaks of cream, rust, gold, and rose. These are jet streams, bands of gas whipping around the planet in opposite directions, creating storms that last not for days, but centuries. Jupiter is not just a planet, it's an atmosphere in motion. Among Jupiter's storms, one stands above the rest, the Great Red Spot, a swirling vortex wider than Earth. The Great Red Spot has been raging for at least 350 years. New research suggests that the Great Red Spot formed about 190 years ago, but despite being younger than previously believed, the storm remains both the largest and longest-lived vortex known across our solar system. It's a hurricane on a planetary scale. Winds howl through it at over 400 kilometers per hour. It changes color, it shifts shape, but it never stops. Why is it red? We're still not sure. Maybe it's chemicals reacting to sunlight. Maybe it's just Jupiter showing off. And it's not alone. Smaller storms pop up like bubbles in a boiling pot. Some merge, some vanish, some last years. The planet's poles host auroras more powerful than any seen on Earth, shaped by a magnetic field 20,000 times stronger than ours. Even from afar, Jupiter pulses with energy. Lightning bolts that flash through thick clouds, magnetic fields that twist space itself. It is a storm cape unlike any other. Jupiter isn't just beautiful, it's essential. Because of its massive gravity, Jupiter acts like a cosmic vacuum cleaner. It attracts or deflects asteroids and comets that might otherwise head toward Earth. It's thought that Jupiter helped shape the early solar system, pulling planets into place, keeping the inner worlds relatively safe. In fact, without Jupiter, life on Earth might never have had a chance to begin, or if it did, it may not have lasted long. So when we look at Jupiter, we aren't just seeing a giant, we're seeing a silent guardian, a protector who's watched over us for billions of years. Jupiter doesn't travel alone. It commands a kingdom of at least 95 moons, each one unique, each one telling its own story. There are the tiny, irregular moons, captured objects, likely leftovers from the solar system's early chaos. But then there are the 4 Galilean moons discovered by Galileo in 1610, each more fascinating than the last. Io, the most volcanically active body in the solar system. Lava erupts constantly, painting its surface in yellows, reds and whites. It's a world of fire. Europa, smooth and icy, but hiding a vast ocean beneath its frozen shell, a possible haven for life, warmed by tidal forces, a world of water and whispers. Ganymede, the largest moon in the solar system, even bigger than Mercury, it has a magnetic field of its own and hints of a subsurface ocean, a moon of giants. Callisto, ancient and cratered, its surface unchanged for billions of years. It holds the memory of the solar system's violent youth, a world of time. These moons are not just sidekicks, they're worlds in their own right. And they may hold the answers to some of our deepest questions. We visited Jupiter many times. Through the eyes of Voyager, Galileo, Juno, and more, we've seen its lightning, measured its fields, flown past its moons. Yet there is still so much we don't know what lies deep within. A solid core, a sea of metallic hydrogen. Jupiter doesn't yield its secrets easily. It keeps its heart hidden beneath layers of pressure and gas, as if to say not yet. But the wonder is in the waiting. Every orbit of Jupiter, every brush with its atmosphere brings us closer to understanding the forces that shaped not only our solar system, but perhaps many others across the galaxy. Jupiter is both a mystery and a memory, a promise and a puzzle. It is the storm that birthed silence, the weight that brought balance. So rest now, dear dreamer. Let Jupiter cradle you in his vast arms. Listen to the whisper of wind through alien clouds. Watch the moons glide silently by. And remember that even in the depths of space, someone is always watching the skies. Saturn, the ringed dancer of the outer skies. Now we sail farther from the sun, beyond the orbit of mighty Jupiter, into the cold, quiet realm where light becomes soft, shadows stretch forever, and beauty takes its grandest form. There in the cosmic ballroom spins Saturn, the sixth planet from the sun, the planet that wears its rings like a crown and twirls in graceful silence. It is a world so lovely, so poetic, that even the cold cannot steal its charm. So close your eyes, dear dreamer, and drift with me. Let's meet the elegant enigma that is Saturn. Saturn is a gas giant like Jupiter, but more delicate. Though it's the second largest planet in our solar system, about 120,000 kilometers across, it's also the least dense. If you could find a cosmic bathtub big enough, Saturn would float. Its atmosphere is made mostly of hydrogen and helium, and its winds can reach speeds of over 1,800 kilometers per hour. But it's quieter than Jupiter, its cloud bands more subdued, its storms more secretive, and yet it has surprises. At the planet's north pole spins a perfect hexagon, a jet ream so vast and precise it defies explanation. This six-sided storm is larger than Earth and has been swirling for decades, perhaps centuries. A planetary snowflake, a mystery drawn in clouds. Beneath the clouds, Saturn's core may be solid rock and ice, wrapped in metallic hydrogen, surrounded by layers of swirling gases, but we don't know for sure. Saturn, ever the gracious host, keeps her center hidden. Saturn's rings are her signature. They stretch more than 280,000 kilometers from the planet, so wide you could fit 21 Earths across them, but they're incredibly thin, only about 10 meters thick in most places, like a lace veil spread across space. Made mostly of water ice, the rings glitter in the sunlight, shimmering in shades of silver, pearl, and soft gold. Some particles are no bigger than grains of sand, others are as large as mountains. The rings are divided into 7 main groups, A, B, C, and so on, with countless smaller divisions in between. Gaps like the Cassini division separate them, voids carved by the gravitational pull of Saturn's moons, dancing in resonance like choreographed whispers, and they're not eternal. The rings may be young, geologically speaking, just 100 to 200 million years old, and they may not last forever. Slowly, they're drifting inward, their icy particles raining down into Saturn's atmosphere. The grand performance will someday end, but for now, dear dreamer, the show goes on. Saturn doesn't spin alone. It rules a court of over 140 moons, icy wanderers, rocky misfits, and some of the most fascinating objects in the solar system. Let's meet a few. Titan, the largest of them all, bigger than Mercury. Wrapped in a thick, golden atmosphere rich in nitrogen, Titan has rivers, lakes, and even rain, but not of water. Here, methane flows like Earth's water. Scientists believe an ocean of liquid water lies beneath its crust. Titan is a world of shadowy orange skies and alien seas, a moon that may harbor life. Enceladus, a bright icy moon with geysers that shoot water vapor and organic molecules into space. Beneath its frozen shell lies a global ocean kept warm by tidal forces. It is one of the best candidates for life beyond Earth. NASA's Cassini probe even flew through its plumes and tasted them. A moon that whispers, "Come closer." Memes, Tethys, Rhea, Dion, each with unique landscapes, craters like empty eyes, canyons carved by ice, and rings of their own materializing around them. These moons don't just orbit, they sculpt the rings, they shape the magnetic field, they interact. Saturn's system is like a miniature solar system, a symphony of balance and motion. We've gazed at Saturn for centuries. Galileo first spotted its rings in 1610, though he didn't know what they were. Later, astronomers like Christian Huygens and Giovanni Cassini would reveal more secrets, moons, gaps, mysteries in motion. In modern times, Saturn has been visited by the Voyagers and orbited by the Cassini spacecraft, a mission that lasted over 13 years. Cassini showed us storms shaped like roses, light glinting off Titan's lakes, shadows sweeping across the rings. It ended in 2017, diving into Saturn's atmosphere in a poetic finale, sending back data until the very last moment. A final waltz with the Queen of Elegance. Saturn is not loud, not violent, not boastful, but it is beautiful. It reminds us that elegance is a kind of strength, that silence can be powerful, that time leaves its mark not only in craters, but in the slow pull of gravity, the drip of ice, the dance of moons. Her rings are fading, her storms are silent, but her grace lingers. And maybe that's the lesson. Everything changes, everything passes, but beauty, true beauty, leaves echoes in the sky. So sleep now, dear dreamer. Let Saturn's rings spin in your imagination. Let Titan's golden haze tuck you in. Drift on Enceladus's icy geysers and dream of dancing with a planet that glides through the dark with dignity and light. Uranus, the sideways whisper of the outer deep. Now we journey even farther from the sun, beyond Saturn's radiant rings, and into the twilight realm, where the stars seem closer than the light, and time flows slow and still. There, hovering in the dusky void, is Uranus, a world both silent and strange. Not as grand as Jupiter, nor as dazzling as Saturn. No fiery volcanoes, no swirling storms that shout for attention. And yet, Uranus has its own kind of beauty. Cool, quiet, elegant, in a way few notice. It leans on its side like a planet lost in thought. It glows softly in hues of aquamarine, and it invites only the most patient dreamers to understand it. Float with me now, dear dreamer, into the frozen elegance of Uranus. Uranus is the 7th planet from the Sun, and the first planet discovered with a telescope. It wasn't known to the ancient sky watchers. It slipped under the radar until 1781, when astronomer William Herschel noticed a star that moved a little too slowly. He had quite accidentally discovered a planet. And what a planet it is! With a diameter of about 51,000 kilometers, Uranus is the 3rd largest planet in the solar system. Like Jupiter and Saturn, it's a gas giant, but with a twist. Uranus belongs to a subcategory called ice giants due to its higher concentration of icy materials like water, ammonia, and methane deep within. Its atmosphere is made mostly of hydrogen and helium, but it's the methane that gives it that dreamy blue-green tint. Methane absorbs red light and reflects blue, a calm, otherworldly glow like moonlight on a glacier. But the most curious thing about Uranus, its tilt. Unlike any other planet, Uranus spins on its side. Its axis is tilted a staggering 98 degrees. Imagine rolling a ball across a floor, not spinning it upright, but sideways. That's Uranus. It doesn't twirl, it lounges. This means its seasons are unlike anything we know. Each pole experiences 42 years of continuous sunlight, followed by 42 years of darkness, a summer of daylight, a winter of night. The rhythm of Uranus is slow and strange and a little bit poetic. Uranus appears serene, almost featureless. But look closely, dear dreamer, and you'll find storms beneath the silence. Its winds, though mostly hidden in the pale atmosphere, can blow at speeds over 900 kilometers per hour. Dark spots, storms, and vortices have been glimpsed through telescopes, moving across the surface like quiet ghosts. Unlike Jupiter's bold bands or Saturn's dancing rings, Uranus keeps its drama beneath a veil. Subtle, icy, whispered. Beneath the clouds, scientists believe a strange, slushy ocean of water, ammonia, and methane lies above a rocky core. This exotic mantle may even generate storms of diamond rain. Yes, you heard that right. Under immense pressure, carbon atoms may crystallize and fall as diamonds through the depths of the planet. Jewels from the sky lost in a sea of ice. Though not as flamboyant as Saturn, Uranus does have rings, 13 of them in fact. Dark, narrow, and faint, they were only discovered in 1977 when they briefly blocked starlight during an occultation. They are made of dark particles, likely coated with carbon-rich material, and they orbit in perfect ghostly alignment with the planet's strange tilt. The innermost ones are tight and thin, the outer rings are broader and more diffuse. They whisper instead of sing. A ring system in shadow, a crown of shadows worn by a king of silence. Uranus has at least 28 known moons, and unlike the other planets whose moons are named after mythological figures, Uranus's moons are named after characters from Shakespeare and Alexander Pope. There's Titania, the queen of the fairies, Oberon, her noble king, Miranda, scarred and strange, with cliffs taller than anything on Earth, Ariel and Umbriel, frozen and pocked with craters. Miranda is perhaps the most haunting. Surface suggests a violent past. Maybe it was shattered and reassembled, or its crust rose and froze in some ancient, icy drama. It looks like a jigsaw puzzle made of frozen time. These moons don't shout, they murmur. They carry tales of long-forgotten impacts and frozen oceans, and they orbit in tilted harmony around a planet that seems forever lost in thought. Uranus has only been visited once by the Voyager 2 spacecraft in 1986. It flew by quickly, snapping photos, measuring fields, and capturing the silence of a planet spinning sideways. No orbiter has ever returned. And so Uranus waits, quiet, distant, unbothered. But interest is growing, new missions are being planned. Scientists want to dive deeper, study its rings, its interior, its storms, its moons. They believe Uranus may help us understand not just our solar system, but others. Ice giants seem common in the galaxy. Uranus might be the key to understanding alien worlds. For now, though, it remains as it is, a sapphire loner, a tilt in time, a whisper in a frozen void. So rest now, dear dreamer. Let Uranus's quiet elegance wrap around your thoughts. Float beneath its turquoise skies. Drift beside its Shakespearean moons. And remember, not all wonders shout. Some simply tilt, glow, and wait to be seen. Neptune, the windswept siren of the outer deep. Now we travel to the farthest known planet in our solar system, a realm where darkness reigns, where the sun appears no brighter than a distant star, and where winds scream across icy clouds at the fastest speeds in the known cosmos. This is Neptune, the 8th planet, the distant guardian of the deep, the silent singer of solar Lys. She is blue as a sapphire, cold as silence, and more mysterious than any of her kin. Named after the Roman god of the sea, Neptune wears her name well. She is fluid, deep, and endlessly captivating. Float with me now, dear dreamer, into her shimmering shadow. Neptune was the first planet discovered not by sight, but by mathematics. In the early 1800s, astronomers noticed something odd. Uranus's orbit wasn't behaving quite as expected. Its path seemed off, tugged by an unseen hand. Scientists like Urbain Lyer and John Couch Adams independently calculated that another planet must be pulling on Uranus. And when telescopes were pointed toward the predicted coordinates in 1846, there it was, Neptune, a planet discovered by logic, by numbers, by curiosity. It was as though Neptune had chosen to remain hidden until someone earned the right to find her. Neptune is nearly 50,000 kilometers across, making it the fourth largest planet by diameter. Like Uranus, it's classified as an ice giant. Its deep atmosphere is rich in hydrogen, helium, water, ammonia, and methane. It's the methane that gives Neptune its brilliant blue hue, a deeper, richer blue than Uranus, as though the planet is made of crushed sapphires and midnight. But behind that beauty lies chaos. Neptune is home to the fastest winds in the solar system, reaching up to 2,100 kilometers per hour. That's faster than the speed of sound. Imagine storms so fierce they could tear through steel, spinning in a world colder than any place on Earth. In 1989, NASA's Voyager 2, the only spacecraft to ever visit Neptune, discovered the Great Dark Spot, a massive storm system the size of Earth. It was a hurricane in the void, a bruise in the planet's atmosphere. When later missions looked again, it was gone, replaced by other storms. Neptune doesn't hold on to her tempests. She lets them pass. She changes. Her atmosphere is layered, dynamic, always in motion. Winds roar. Clouds form and vanish, the sky churns. Neptune is not a frozen statue. She's an ocean of gas dreaming in currents. Beneath Neptune's blue clouds lies a slushy, super-pressurized mantle, a strange exotic ocean made of water, ammonia, and methane. Deeper still, a rocky core, possibly surrounded by a diamond rainstorm, much like her cousin Uranus. Despite being far from the Sun, more than 4.5 billion kilometers away, Neptune radiates more heat than it receives. It has an internal engine, a warmth that defies its distance. Scientists aren't entirely sure why. Is it residual heat from its formation, a slow gravitational contraction, a quiet fire beneath the waves? Even out here, so far from the Sun's touch, Neptune glows with hidden energy. Neptune has a faint system of rings, 5 main ones made of dark particles, thin and wispy, like smoke caught in a sunbeam. They're hard to see, even with telescopes, but they are real. The planet wears them like soft threads in a midnight shore. And then there's Triton. Triton is Neptune's largest moon and one of the most fascinating in the entire solar system. It's a frozen world with geysers of nitrogen ice that erupt like ghostly fountains falling back in delicate arcs. Its surface is a patchwork of ridges, plains, and bizarre cantaloupe terrain. But here's the strangest part. Triton orbits Neptune backwards, a retrograde motion suggesting it was once a free object, perhaps a dwarf planet captured by Neptune's gravity. A reluctant companion, a cosmic refugee. Triton is also believed to have a subsurface ocean, and where there's water, there may be life. Even out here, life could be sleeping beneath the ice. Neptune marks the edge. Beyond her lies the Kuiper Belt, the scattered ice fields, the icy bodies like Pluto, Ice, and Haumea. Beyond that, the great black unknown. But Neptune is not an end. She is a transition, a portal between the known and the mysterious. She teaches us that even in the coldest reaches there is motion, beauty, power. She is proof that even at the edge of the sun's light, the universe still sings, and she is patient, waiting for us to return. Voyager 2 passed her by, took photos, measured winds, then flew on into the stars. No spacecraft has been back since, but one day we will return. And she will still be here, spinning slowly in her endless ballet, wrapped in blue, watching the stars like a dreamer herself. So sleep now, dear dreamer. Let Neptune's winds carry your thoughts. Let Triton's geysers mist your dreams. Let the quiet of the outer solar system remind you that even the coldest corners hold warmth, wonder, and motion. Pluto, the lonely heart at the edge of the light. Now we leave the realm of giants and gas, moons and rings, and sail into the quiet beyond the Kuiper belt. Out here, the sun is but a distant glimmer, and space stretches wide and still. In this frozen deep drifts a world once hailed as the 9th planet, a tiny sphere wrapped in ice and shadow, a body so small it could fit into the United States, yet so beloved it captured the imaginations of millions. This is Pluto. It may no longer wear the title of planet, but it remains a symbol of wonder, resilience, and the ever-evolving nature of science. Let us tell its story together, dear dreamer, with reverence, warmth, and just a touch of rebellion. In the early 20th century, astronomers noticed oddities in the orbits of Neptune and Uranus. They suspected another planet, Planet X, was tugging at them with unseen gravity. Enter Clyde Tombaugh, a young farm boy turned astronomer, scanning the night sky from a chilly observatory in Arizona. In 1930, after countless hours hunched over photographic plates, he spotted it. A tiny dot moving slowly against the backdrop of stars. Pluto had been found. Named by an 11-year-old British girl, Venetia Burney, after the Roman god of the underworld, Pluto was the perfect name for this dark, distant world. It honored myth, mystery, and shadow. For decades, Pluto held its place as the 9th planet. Small, yes, but proud. Quiet, but claimed. Pluto is tiny, about 2,400 kilometers across, smaller than our moon. But what it lacks in size, it makes up for in personality. It has a heart, a literal one, a vast, bright glacier shaped like a heart, named Tombaugh Regio, made of nitrogen ice. It shines with reflective beauty. It pulses with Pluto's soul. In 2015, NASA's New Horizons spacecraft flew past Pluto, giving us our first close-up look. And what we saw, breathtaking. We saw mountains made of water ice, smooth plains with no craters, suggesting geological activity. We saw blue skies, hazy layers of atmosphere, and possible signs of cryovolcanoes, volcanoes that erupt ice instead of lava. Pluto may be small, but it's alive with stories. Pluto doesn't drift alone. It has 5 known moons. The largest, Charon, is nearly half Pluto's size. So close and so big that the two bodies orbit a point outside Pluto's surface, making them a binary system, a cosmic duet. Charon's surface is scarred with chasms and cliffs, suggesting a once active interior. It even has a strange red stain near its pole, possibly made of organic molecules, its own quiet mystery. Then there are the smaller moons, Nix, Hydra, Kerberos, and Styx, all named for figures from the underworld, spinning like icy dancers around their distant parent. Together they form a family, odd, asymmetrical, but full of rhythm and care. But Pluto's story took a turn in 2006. The more we looked into the Kuiper belt, the more small, icy worlds we found. Some were even close in size to Pluto, like Eris, Macon, Hela. Suddenly, Pluto wasn't alone and wasn't so unique. Astronomers had to decide, were all these icy bodies planets, or was the definition too loose? The International Astronomical Union, IAU, stepped in with new criteria for what counts as a planet. It must orbit the Sun. It must be spherical due to its own gravity. It must have cleared its orbit of other debris. Pluto failed that third point. It shares its neighborhood with countless icy cousins. And so Pluto was reclassified as a dwarf planet. The internet wept. Children wrote angry letters. Grown adults gasped in horror. A whole generation felt as though someone had taken away their childhood planet. But science wasn't trying to erase Pluto. It was refining its understanding, naming things more precisely, learning. Pluto didn't shrink. Our knowledge just expanded. Today, Pluto floats at the heart of the Kuiper Belt, a frozen realm of leftover building blocks from the early solar system. It's a relic, a survivor, a messenger from the past. New Horizons showed us not just a planet, but a poetic world, a world with weather, with shifting ice, with a strange internal heat, a world that may still hold secrets in its frozen core. And though it no longer wears the planet label, Pluto has gained something deeper: affection, mystery, a legacy. It teaches us that names change, but wonder doesn't. That size isn't what makes something important. That even the smallest things in the universe can capture our biggest feelings. So, sleep now, dear dreamer. Let Pluto cradle you in its icy arms. Let its quiet heart beat beside your own. Drift with Karen. Dance through the distant dark and know that being different is sometimes the most beautiful thing of all. Black holes, the silent thieves of light and time. Now we leave behind the comfort of stars and planets. We drift beyond the shining, the spinning, the known. Out here, in the darkest corners of the cosmos, lie the great enigmas, regions so dense, so powerful, that not even light can escape them. They are not monsters. They are not holes. They are the echoes of stars, the scars of collapse, the keepers of cosmic secrets. They are black holes. Come closer now, dear dreamer. No need to fear. They may swallow light, but they can illuminate the soul. To understand a black hole, we must first meet a dying star. Massive stars, those much larger than our sun, spend their lives fusing hydrogen into helium, then heavier elements like carbon and oxygen until they reach iron. But iron cannot release energy through fusion, so the star falters. Gravity, always waiting, takes control. The star collapses in on itself suddenly, violently. The outer layers explode in a glorious supernova, lighting up the galaxy. But the core, it keeps falling, compressing, crushing. If the star was massive enough, that collapse doesn't stop. The core is squeezed so tightly that it forms a singularity, a point of infinite density where physics, as we know it, breaks down. Around it, space folds inward. A boundary forms called the event horizon. Once crossed, nothing returns. A black hole is born not from chaos, but from surrender. Black holes come in many sizes. Stellar black holes formed from collapsing stars are only a few kilometres wide, but can contain more mass than several suns. Intermediate black holes may form when stars cluster and merge, still elusive, still mysterious. And then there are the supermassive black holes, millions or even billions of times the mass of our sun. These beasts lurk at the centers of galaxies, including our own. Our Milky Way hosts one Sagittarius, a star, a supermassive black hole over 4 million times the mass of the sun, hiding behind veils of dust. feeding slowly on stars and gas. But here's the thing, black holes don't suck. They don't go around hoovering the universe. If our sun were replaced with a black hole of the same mass, Earth would keep orbiting. Cold, yes, but untouched in its path. Black holes only affect what gets too close. The event horizon is the point of no return. Cross it, and nothing can escape. Not ships, not screams, not light itself. To an outside observer, time appears to slow for anything approaching this boundary. A spaceship, for example, would seem to freeze, inching ever closer, but never quite reaching the edge. Its signals would stretch into red oblivion. It would fade like a sigh in reverse. But to the traveler aboard, time feels normal until it isn't. As they pass the horizon, they fall inward. There is no stopping, no turning back. Space becomes warped. Time becomes tangled. Inside the singularity awaits the point where density becomes infinite and gravity pulls inward through dimensions. What happens there? No one knows. Our current physics breaks apart. Perhaps reality too. But black holes don't only take, they give too, though not in the usual ways. Around many black holes, matter swirls in glowing disks. Accretion disks heated to millions of degrees as it spirals inward. These disks can emit X-rays and radiation, outshining entire galaxies. Sometimes jets of plasma burst from the poles at near light speed, launched by twisted magnetic fields. These jets can stretch for thousands of light years, painting space with the fingerprints of the unseen. And thanks to genius minds like Stephen Hawking, we know black holes may not be eternal. Hawking proposed that they emit tiny amounts of energy over time, Hawking radiation. Slowly, subtly, they may evaporate. Even black holes, it seems, do not escape the cycle of creation and loss. For centuries, black holes were just theory, feared, doubted, imagined. But then we saw one. In 2019, the Event Horizon Telescope gave us the first image of a black hole's shadow, a glowing ring around darkness in the galaxy M87. That image wasn't just a scientific feat, it was a poem made of photons. We captured the silhouette of a cosmic phantom. And we're not done. New observations, new telescopes, new minds are working to unravel these mysteries. Black holes are now tools, probes for testing gravity, quantum theory, time itself. They may one day unlock answers about the beginning of everything and what comes after the end. So rest now, dear dreamer. Let the pull of the cosmos rock you to sleep. The black holes will still be here, silent, patient, swirling in the dark. They don't need light to shine. They shine in questions. The Big Bang, the first whisper of everything. Now, dear dreamer, we drift beyond planets, moons, and stars, beyond the solar winds, the galaxies, and even the fabric of space itself. We are going home, not to Earth, not even to the Milky Way, but to the very beginning, to a moment before moments, before light, before time, before there was anything to see or feel or name. This is the story of the Big Bang, the first heartbeat of the cosmos, the spark from which all dreams, dust, stars, and kisses were born. Come now, dear dreamer, let us begin at the beginning. It's hard to imagine, but once everything in the universe, everything was packed into an impossibly small, unimaginably dense point, a singularity. No space, no time, just potential, like the silence before a song, like breath held in eternity. Then about 13.8 billion years ago, it happened. The universe expanded rapidly, violently, beautifully, not into space, but creating space as it grew. In a trillionth of a second, the universe grew from smaller than an atom to the size of a galaxy. Light was born, time began to tick, Particles began to dance, and from that moment everything began. In those first fleeting moments, the universe was hot, blisteringly, unimaginably hot, a soup of particles whirling and colliding, quarks, gluons, photons, electrons, all tangled in a wild cosmic waltz. But even chaos has its rhythm. As things cooled just enough, particles began to combine. Quarks became protons and neutrons. Then after about 3 minutes, yes, minutes, those formed simple atomic nuclei, hydrogen, helium, and a little lithium. Still too hot for atoms, but the seeds were there. The building blocks of everything, stars, oceans, giraffes, you. And then after 380,000 years, a blinking cosmic time, the universe cooled enough for atoms to finally form. Light was no longer trapped. It could move freely. At first, light still echoes through space today. We call it the cosmic microwave background, the afterglow of creation, the oldest light you can possibly see. After that first flash, the universe went dark for a while, a cosmic night. But inside that darkness, gravity was at work, pulling, gathering. Tiny variations in density, ripples in the early universe began to clump matter together. Hydrogen gas collected into clouds, clouds into knots, knots into stars. The first stars ignited, giants, blue, white, and brief. They lived fast, burned hot, and exploded in spectacular supernova, creating heavier elements like carbon, oxygen, iron, and gold. From these starbursts, galaxies began to form, billions of them, each with billions of stars. The universe was waking up, spreading out, lighting up. And somewhere far down the line, one quiet little star would be born in the outer spiral arm of one galaxy. Around it, a few rocky planets would form. On one of them, life would begin. And eventually you would hear these words. You would hear this story. You would hear my voice. Since that first moment, the universe has never stopped expanding. Even now, space itself stretches. Galaxies move farther apart. The stars are still dancing. And you, dear dreamer, are made of that same ancient stardust. The hydrogen in your body is over 13 billion years old. The calcium in your bones was born in a dying star. The iron in your blood was forged in cosmic fire. You are not just in the universe, you are of it. A breathing echo of the Big Bang, a living whisper of eternity. What lies ahead? The universe may continue expanding forever, growing colder and dimmer with time, or maybe gravity will someday slow it down, or dark energy, a force we barely understand, might accelerate it toward a fate of endless isolation. We don't know. But the story continues. Every supernova, every planet born, every photon that zips across space is part of the unfolding narrative. And so are you. The same laws that shaped galaxies shaped your laughter. The same particles that form stars now shimmer in your thoughts. You are the cosmos thinking about itself. So rest now, dear dreamer. The stars are older than time, but they still burn for you. Let the echo of that first light cradle your sleep. Let the quiet of space remind you that from emptiness can come everything. Nicholas Copernicus, the architect of the heavens. In the quiet town of Torun, Poland, in the year 1473, a child was born who would change the course of human understanding forever. His name was Nicholas Copernicus. Though the world he entered believed the earth to be the center of all things, he would grow to be the man who dared to suggest otherwise. Copernicus's early years were steeped in both privilege and tragedy. His father, a well-respected merchant, passed away when Nicholas was just 10 years old, leaving his education and upbringing to his uncle, a powerful bishop. It was under his uncle's guidance that Copernicus pursued higher learning. He studied at the University of Kov, where he was introduced to mathematics and astronomy, disciplines that would become the pillars of his life's work. After Kov, Copernicus travelled across Europe, furthering his education in Italy. He immersed himself in medicine, law, and theology. Yet his heart remained with the stars. He became fluent in Latin, Greek, and Italian, allowing him access to the great works of antiquity. But it was not the past he sought to understand, it was the future of human knowledge. By day, Copernicus served as a cleric and physician, tending to administrative duties and aiding the sick. But by night, he turned his gaze skyward, tracking the celestial dance of planets and stars. Over time, he grew increasingly troubled by the atomic model of the universe. The long-accepted system that placed Earth at the center with the Sun and planets orbiting around it. The model, though widely accepted, was riddled with inconsistencies. The retrograde motion of planets, their apparent backward movement in the sky, was difficult to explain within this framework. Determined to find a simpler, more elegant truth, Copernicus embarked on his great work. Through years of meticulous observation and calculation, he arrived at a radical conclusion. The Sun, not the Earth, was the true center of the universe. The planets, including Earth, revolved around it in a grand cosmic ballet. This was the heliocentric model, and though it made logical and mathematical sense, it was an idea that could upend the very foundation of human belief. For years, Copernicus hesitated to publish his findings. He knew that such a claim could be met with resistance from religious and political authorities. The idea that Earth was not the fixed center of creation challenged deeply held convictions, and the consequences of such defiance were potentially severe. So he worked in secret, refining his theories, seeking perfection in his calculations. It was not until the urging of his friends and students that he finally agreed to publish his masterpiece Ruvolium Orbium Celestium on the revolutions of the celestial spheres. The book, printed in 1543, was a work of quiet rebellion. Copernicus, now in his 70s and gravely ill, is said to have received the first printed copy on his deathbed just before passing away. The impact of his work would not be immediate. Many dismissed it as theoretical, too radical to be accepted. The Catholic Church remained largely indifferent at first, not fully grasping its implications. But in time, as others built upon his ideas, Galileo, Kepler, and eventually Newton, the truth of his vision became undeniable. Despite the initial resistance, the heliocentric model would lay the groundwork for modern astronomy. The stars and planets were no longer bound to an Earth-centered reality, but were part of an ever-expanding universe governed by mathematical precision and natural laws. Tonight, as you look up at the night sky, imagine the quiet, contemplative figure of Nicholas Copernicus sitting at his desk centuries ago, pen in hand, charting the heavens with quiet certainty. He did not seek fame, nor did he crave revolution. He only sought truth, and with his work he handed humanity the key to understanding the vast, intricate cosmos in which we reside. So sleep well, dear dreamer, and remember that even the simplest questions, why do the planets move as they do, can lead to the greatest discoveries of all time. Galileo Galilei, the watcher of the heavens. In the golden glow of the 16th century Italy, a young boy named Galileo Galilei gazed at the sky with wonder. Born in Pisa in 1564, he grew up amidst the melodies of music and the precision of mathematics. His father being both a musician and a keen intellect, Though he initially studied medicine at the University of Pisa, it was the pull of mathematics and physics that captured his soul. Galileo was a restless thinker, always questioning, always seeking. He was fascinated by motion, by the way objects fell, rolled, and moved through the world. In his early career, he became a professor of mathematics in Padua, where he refined his ideas on physics, motion, and the very nature of reality. But the heavens, those distant, untouchable lights in the sky, called to him more than anything else. One evening in 169, Galileo pointed a telescope, his own refined creation, toward the night sky, changing the course of history forever. With that humble instrument, he unlocked a universe never before seen by human eyes. The moon, long thought to be a perfect divine sphere, was revealed to be rough, scarred with mountains and valleys. Jupiter, the great gas giant, was not alone, but accompanied by 4 orbiting moons: Io, Europa, Ganymede, and Callisto. The Milky Way, a cloudy band stretching across the heavens, was not a mist, but an expanse of countless stars. But perhaps his most daring revelation was the truth that the Earth was not the unmoving center of the universe. Inspired by the work of Copernicus, Galileo confirmed that the planets orbited the Sun, not the other way around. This idea, though supported by evidence, was dangerous. The world he lived in was governed by strict religious beliefs, and challenging them meant defying some of the most powerful authorities of his time. His discoveries were not met with universal praise. Many of his peers scoffed at his findings, unwilling to accept that the universe was different from what they had long believed. Yet Galileo was fearless, publishing his observations and defending the heliocentric theory with unwavering conviction. His work, Sidarius Nunius, the Starry Messenger, sent shockwaves through the intellectual world. He was hailed by some, condemned by others, but opposition grew. The Church, which had long upheld the geocentric view of the cosmos, saw Galileo's work as a direct challenge to its teachings. In 1616, he was warned to abandon his support of heliocentrism. For a time, he complied, retreating into silence. However, in 1632, his passion for the truth could no longer be contained. He published dialogue concerning the 2 chief world systems, a masterful argument for the sun-centered cosmos. It was written as a conversation between 3 thinkers, one supporting Copernicus, one defending the old ways, and one acting as an impartial observer. But the message was clear, and it was one the Church could not ignore. Galileo was summoned to Rome, put on trial for heresy. The Inquisition, an institution that sought to root out unorthodox beliefs, declared his teachings dangerous. Under threat of imprisonment or worse, he was forced to recant his findings. Kneeling before his judges, he uttered the words they demanded, but legend tells us that as he rose, he whispered, "Eppo!" And yet it moves. Galileo spent the remainder of his life under house arrest. His books censored, his voice silenced, but his mind never stopped soaring. Even in confinement, he continued to write, penning 2 new sciences which laid the groundwork for modern physics. His ideas, though condemned in his time, became the foundation for future scientists like Newton, Einstein, and music beyond. As the years passed, history vindicated Galileo. The Church, centuries later, admitted its error. His name became a symbol of courage, of relentless pursuit of truth in the face of adversity. He was not just an astronomer, not just a scientist, but a beacon of human curiosity and resilience. Tonight, as you gaze at the moon, know that once, long ago, a man named Galileo looked up at that same moon and saw it not as divine perfection, but as a world of craters and mountains, and in doing so he brought humanity one step closer to the stars. Johannes Kepler, the mathematician of the stars. In the year 1571, under the cold, vast skies of the Holy Roman Empire, a child was born into a world of war, superstition, and hardship. His name was Johannes Kepler. And though he came into life frail and sickly, his mind was destined to be one of the strongest in the history of astronomy. Kepler's early years were marked by struggle. Born into poverty, his father was a mercenary who would later disappear, and his mother was an herbalist accused of witchcraft. Yet despite these challenges, young Johannes showed extraordinary promise. His sharp mind and fascination with the heavens earned him a scholarship to the University of Tübingen, where he studied mathematics and astronomy. There he encountered the heliocentric theories of Copernicus, an idea that would captivate him for the rest of his life. After completing his studies, Kepler became a mathematics teacher in Graz, Austria. It was here that the cosmos called him in earnest. He saw divine order in the stars and believed that the universe followed mathematical laws, a belief rooted in both his scientific mind and deep religious convictions. But just as his work was beginning, the tides of history intervened. Religious persecution forced Kepler to leave Graz, and he eventually found refuge in Prague under the employment of Tycho Brahe, the famed Danish astronomer. Brahe was the most meticulous observer of the heavens of his time, compiling vast amounts of data on planetary positions. Kepler, armed with his brilliant mathematical mind, became his assistant. It was a fateful pairing. Though the two men had starkly different personalities, Brahe was a flamboyant nobleman, Kepler a humble intellectual. Their collaboration would change astronomy forever. When Brahe died in 601, Kepler inherited his work. Sifting through the mountains of observational data, he sought patterns, laws, truths that governed the movement of the planets. What he discovered shattered centuries of belief. The ancient assumption that planets moved in perfect circles was wrong. Instead, Kepler found that planets traveled in elliptical orbits, a revelation that defied classical thinking, but fit the observational evidence perfectly. This became the first of his famous 3 laws of planetary motion. Planets move in elliptical orbits with the Sun at one focus. A planet sweeps out equal areas in equal times, meaning they move faster when closer to the Sun and slower when farther away. The square of a planet's orbital period is proportional to the cube of its distance from the Sun. These laws form the foundation of celestial mechanics and set the stage for Isaac Newton's later work on gravity. They explain planetary motion with breathtaking precision, bringing order to the celestial dance that had puzzled humanity for millennia. But Kepler's life was far from easy. He lived in an era of turmoil plagued by religious conflict, financial hardship, and personal tragedy. He lost his first wife and several children to illness. He endured exile and the burning of his books. Even his mother was imprisoned for witchcraft, and Kepler fought tirelessly for her release. Through it all, he never abandoned his pursuit of truth. Beyond his scientific work, Kepler was also a visionary. He wrote Somnium, one of the first works of science fiction, which imagined a journey to the moon. He pondered the existence of other worlds, other suns, long before such ideas were widely accepted. He dreamed of a universe far grander than anyone of his time could have conceived. As he aged, Kepler continued to push the boundaries of knowledge. He spent his final years refining his astronomical tables known as the Rudolphine tables, which dramatically improved the accuracy of celestial predictions. These tables would guide astronomers and navigators for centuries. Kepler passed away in 1630, weary but fulfilled, having glimpsed the hidden architecture of the cosmos. His name would later be immortalized in the Kepler Space Telescope, a tribute to his relentless search for order in the stars. Tonight, as you gaze upon the night sky, think of Johannes Kepler, the man who against all odds unveiled the elegant mathematics behind the movement of the planets. He saw the universe not as chaos, but as a celestial symphony, governed by laws that humankind could understand, and in doing so he brought us closer to the stars. So sleep well, dear dreamer, and know that the universe vast and boundless is not random, but a masterpiece of intricate beauty, waiting to be explored. Tycho Brahe, the stubborn visionary of the stars. The year was 1546, and in a grand castle in Denmark, beneath the watchful gaze of the northern sky, a child was born into nobility. His name was Tycho Brahe, and though he would inherit wealth and privilege, his true legacy would be written not in gold, but in the stars. Tycho's early life was marked by an unusual twist of fate. Though born to noble parents, he was taken, some say, kidnapped by his wealthy uncle, who raised him as his own, ensuring he received the finest education. From a young age, Tao was captivated by astronomy. Though his family had different plans, they wanted him to study law. But fate, as it often does, had other ideas. At the age of 13, Tao witnessed something extraordinary. A solar eclipse precisely predicted by astronomers. It was a revelation. How could mere humans with nothing but numbers and instruments predict the movements of celestial bodies? The question consumed him, and despite his family's wishes, he dedicated himself to the study of the stars. Though he briefly attended university to study law, he secretly pursued astronomy. One night he observed a rare event, a conjunction of Jupiter and Saturn, but the predicted positions of these planets was slightly incorrect. It was a small discrepancy, but to Tao it was unacceptable. If the cosmos was to be understood, it had to be understood precisely. Determined to create better astronomical measurements, Tycho left behind traditional law and devoted himself fully to science. He traveled across Europe, learning from the best minds of his time, gathering knowledge like a traveler collects stars in a bottle. But his greatest opportunity came when King Frederick II of Denmark recognized his genius and granted him an island, Ven. On this secluded island, Tao built a marvel, Uraniborg, the most advanced astronomical observatory of the 16th century. Unlike most astronomers of his time who relied on small instruments and rough calculations, Tycho constructed massive, intricate devices to chart the movements of the heavens with unparalleled accuracy. His observations were so precise that they would remain unmatched for decades, despite the fact that he worked without a telescope. For years, Tao meticulously tracked the stars and planets. His work led to the discovery of something that defied the old beliefs of the cosmos. In 1572, he observed a bright new star, a nova, in the seemingly unchanging heavens. According to the ancient belief, the celestial sphere was perfect and immutable. But this new star proved otherwise. The universe was not fixed. It could change. Tao had uncovered evidence that the heavens were dynamic, a revelation that challenged centuries of thought. But Tao was not just a man of science. He was a man of contradictions. He was brilliant, yet arrogant, meticulous, yet eccentric. He wore extravagant clothes, kept a pet elk that reportedly died after drinking too much beer, and even had a metal nose, a result of losing part of his real one in a duel over a mathematical dispute. He was known for his stubbornness, unwilling to fully embrace the heliocentric model proposed by Copernicus, instead advocating for his own hybrid system where the planets orbited the Sun, but the Sun, in turn, orbited the Earth. Despite his brilliance, Tycho's fortunes changed after the death of King Frederick II. Losing royal favour, he was forced to leave Herven, taking his invaluable records with him. Eventually he found refuge under the Holy Roman Emperor Rudolf II in Prague, where he continued his work. It was here that he met Johannes Kepler, a mathematician destined to change the course of astronomy. The two men could not have been more different. Tau the nobleman, proud and commanding, and Kepler the poor, brilliant, deeply introspective thinker. Their collaboration was turbulent but essential. Tau provided Kepler with the most accurate planetary data ever recorded, while Kepler, using this data, would later derive his revolutionary laws of planetary motion. In 6001, Tycho Brahe passed away suddenly under mysterious circumstances. Some say he was poisoned. Others claim it was an infection from refusing to leave a royal banquet due to courtly etiquette. Whatever the cause, his death marked the end of an era. But his legacy was far from over. Kepler inherited Tycho's data, and using it, he unlocked the truth that had eluded even his mentor. Planets did not move in perfect circles, but in ellipses. Without Tycho's precise observations, Kepler's breakthroughs may never have been possible. Tycho Brahe was a man of paradoxes, arrogant yet brilliant, stubborn yet visionary. He refused to embrace the full reality of a heliocentric universe, yet his work paved the way for those who did. He measured the heavens with a precision never before achieved, bringing humanity closer to understanding its place in the cosmos. Tonight, as you gaze up at the stars, think of the man who devoted his life to measuring them with extraordinary care. The man who built an island observatory, who lost his nose in a duel, who kept an elk as a drinking companion, and who, despite his eccentricities, left behind a treasure trove of knowledge that changed the world forever. So sleep well, dear dreamer, and remember that the universe rewards those who dare to question, to measure, and to see beyond what others accept as truth. The stars above shine with the echoes of those who have studied them. And among those echoes is the legacy of Tycho Brahe, the last great astronomer of the naked eye era. Edmund, the man who chased a comet. In the year 1656, beneath the overcast skies of London, a child was born into a world filled with uncertainty, discovery, and wonder. His name was Edmund Halley, and though his name would become synonymous with a celestial visitor that graces Earth's sky every 76 years, his contributions to science reached far beyond the glowing trail of a comet. From a young age, Halley displayed an insatiable curiosity. His father, a wealthy merchant, ensured that he received the finest education available. He attended St. Paul's School, where his brilliance in mathematics and astronomy became evident. By the time he entered the University of Oxford at just 17 years old, he was already a keen observer of the heavens, eager to unravel the mysteries of the cosmos. Hall's first major journey took him across the seas. In 1676, at the age of 20, he set sail for the remote island of St. Helena in the South Atlantic Ocean. His mission to map the southern stars, something that had never been done with great precision before. The expedition was fraught with difficulty. Storms, illness, and the harsh conditions of the island threatened to derail his work. Yet Halley persevered, charting hundreds of stars with remarkable accuracy. When he returned to England, his findings were so impressive that he was elected a Fellow of the Royal Society before he had even completed his degree. His contributions to astronomy were vast. He studied the movement of stars and planets, delving into the mechanics of celestial motion. But Halley was more than just an astronomer. He was a man of many sciences. He explored Earth's magnetic field, mapped trade winds, and even conducted one of the earliest studies on the age of the planet by examining the rate at which rivers deposited silt into the sea. His mind was as boundless as the universe itself. Yet it was his encounter with a fellow scientist that would shape the course of history. Halley met Isaac Newton, a brilliant but secretive thinker who had devised groundbreaking theories of motion and gravity. Recognizing the importance of Newton's work, Halley urged him to publish his findings. But Newton hesitated, reluctant to enter the fray of scientific debate. It was Halley who funded and facilitated the publication of Philosophia Naturalis Principia Mathematica, the work that would become the foundation of modern physics. Without Halley's encouragement, the world may have waited decades for Newton's laws of motion and universal gravitation to be revealed. But Halley's own most famous discovery was yet to come. For centuries, comets had been seen as omens, unpredictable visitors streaking across the sky. Halley, however, saw them as something more, something governed by the same celestial laws that ruled the planets. By analyzing historical records and applying Newton's laws of motion, he studied the paths of comets recorded in 1531, 607, and 1682. He noticed something astonishing. Their orbits were strikingly similar. He made a daring prediction. These were not three different comets, but the same comet returning in a regular, predictable cycle. He proposed that it would return again in 1758. Sadly, Halley did not live to see his hypothesis proven correct, as he passed away in 1742. But when the comet reappeared in the predicted year, it bore his name, Halley's Comet. Halley's scientific contributions did not end with his work on comets. He was also instrumental in the early study of Earth's atmosphere, meteorology, and oceanography. He investigated the properties of air pressure, the effects of climate on navigation, and even designed an early prototype of the diving bell, allowing explorers to remain underwater for extended periods. His diverse range of studies demonstrated a mind unshackled by rigid disciplines, forever seeking knowledge in every direction. As the years passed, Halley continued to serve the scientific community. He was appointed Astronomer Royal in 1720, succeeding the legendary John Flamsteed. Despite his advancing age, he continued his work, tirelessly observing the moon and refining techniques for measuring longitude at sea, a crucial endeavour for the British Empire's growing naval ambitions. Even in his later years, Halley's passion for discovery never waned. He remained a visionary, pushing the boundaries of what was known. Though he would not see the return of his predicted comet, he left behind a legacy that ensured his name would be forever tied to the heavens. The legacy of Edmund Halley reaches far beyond the comet that graces Earth's skies. His work bridged the worlds of astronomy, physics, and geophysics, laying the foundation for future discoveries. He was a man who saw patterns where others saw chaos, who championed science in an era where belief often clashed with reason. Tonight, as you look up at the sky, remember Edmund High, the man who dared to predict the movement of a celestial wanderer, who helped bring Newton's ideas to the world, and who taught us that the universe, for all its vastness, moves in rhythms we can understand. So sleep well, dear dreamer, and know that just as Halley mapped the heavens, your own journey is guided by the light of knowledge, forever pushing you toward new discoveries. William Herschel, the musician who discovered worlds. In the year 1738, in the bustling city of Hanover, Germany, a child was born into a world filled with music. His name was Friedrich Wilhelm Herschel, known to history as William Herschel. Though his early life was dedicated to melody, fate had something grander in store for him. He would become one of the greatest astronomers of all time, a man who gazed into the depths of space and discovered worlds beyond what anyone had ever imagined. Born into a family of musicians, young William's life revolved around notes, harmonies, and compositions. He played the oboe, violin, and harpsichord, and by the age of 14 he was already performing with the Hanoverian military band. However, war disrupted his path. As conflict loomed, William and his brother fled to England, where he rebuilt his life as a musician. For years he worked as a composer and organist, performing in Bath, a city renowned for its cultural vibrancy. Music was his livelihood, but the stars were his passion. By night, after long hours of rehearsals and performances, Herschel turned his gaze toward the heavens. He devoured books on astronomy and mathematics, eager to understand the universe beyond his earthly stage. But he found himself frustrated. Telescopes at the time were limited in power, unable to reveal the wonders he suspected lay beyond sight. Determined to see further, he decided to build his own. With the help of his sister Caroline Herschel, who would become a remarkable astronomer in her own right, William began grinding and polishing mirrors, constructing telescopes that far surpassed those available in his time. His dedication paid off. By 1774, he had built a powerful reflector telescope and turned it toward the night sky. What he saw would change the course of astronomy. On the night of March 13th, 1781, Herschel observed something unusual. A small, faint object moving against the backdrop of fixed stars. At first, he believed it to be a comet, but as he tracked its motion, he realized the truth. It was a planet, one that no one had ever seen before. He had discovered Uranus, the first planet to be identified with a telescope, shattering the long-held belief that only 6 planets existed in our solar system. The discovery sent shockwaves through the scientific world. It was the first new planet discovered since ancient times, proving that the solar system was far larger than previously believed. King George III, eager to support the man who had uncovered this new world, granted Herschel a pension and named him the Royal Astronomer. The musician turned astronomer had rewritten the cosmos. But Herschel did not stop there. With his sister Caroline by his side, he embarked on an ambitious journey to map the heavens. He meticulously catalogued thousands of stars, uncovering double stars, nebula, and star clusters. He was the first to realize that these celestial objects were not random, but part of a grander cosmic structure. His observations laid the foundation for the discovery of galaxies beyond our own. One of Herschel's most profound contributions was his study of infrared radiation. By passing sunlight through a prism and measuring the temperature beyond the visible spectrum, he discovered a form of light invisible to the human eye. This revelation would later become crucial in the fields of physics and astronomy, changing our understanding of energy and heat. Meanwhile, Caroline Herschel, once his assistant, became an esteemed astronomer in her own right. She discovered comets, catalogued nebulae, and became the first woman to receive a salary for scientific research. The Herschel were more than a family. They were pioneers of the cosmos. As the years passed, William Herschel continued his relentless pursuit of knowledge. He built ever larger telescopes, including a massive 40-foot reflector, the most powerful of its time. With it, he peered deeper into space than anyone before him, revealing the structure of the Milky Way and suggesting that our galaxy was just one among many. Herschel's work redefined the way humanity saw the universe. He was not just an astronomer, he was an explorer, a dreamer who turned his back on the stage of Earth to perform in the vast theatre of the stars. His legacy remains in every telescope that scans the heavens, in every astronomer who seeks the unknown, and in the countless discoveries that followed in his wake. Tonight, as you look at the sky, imagine the hands of William Herschel carefully adjusting his telescope, searching for something more. He was a man who believed that the universe was far greater than anyone dared to dream. And he proved it true. So sleep well, dear dreamer, and know that like Herschel, you too can reach beyond the horizon, beyond what is known into the vast and wondrous unknown. Christian Huygens, the visionary of light and planets. In the year 1629 in the Dutch Republic, a child was born into a world brimming with artistic brilliance, scientific discovery, and the hum of intellectual revolution. His name was Christian Huygens. And though he lived in an era of great thinkers, his genius would shine as one of the brightest. A polymath who delved into astronomy, physics, and mathematics, Huygens was destined to unravel some of the universe's most profound mysteries. From an early age, Christian was surrounded by knowledge. His father, Constantine Huygens, was a poet, diplomat, and musician, deeply embedded in the cultural and intellectual circles of Europe. Under his guidance, Christian developed a deep love for science and mathematics, quickly surpassing his tutors in skill. He had a particular gift for seeing patterns in nature, an ability that would later define his scientific breakthroughs. Though he explored many fields, it was the cosmos that captivated him most. The 17th century was a time of astronomical awakening, and the telescope had opened new doors to the heavens. Inspired by the work of Galileo, Huygens sought to improve upon existing optical technology. With meticulous care, he ground lenses of extraordinary quality, constructing some of the finest telescopes of his era. His efforts would lead to discoveries that would change humanity's understanding of the solar system. In 1655, while peering through one of his telescopes, Huygens observed something astonishing, a large moon orbiting Saturn. This moon, which we now call Titan, was the first moon discovered beyond those of Jupiter. It was a revelation that hinted at the vast complexity of the outer planets, suggesting that Saturn was not alone in its grandeur. But Huygens' work with Saturn was far from over. The rings of Saturn had long puzzled astronomers, appearing as strange appendages or handles to those with less refined instruments. Galileo himself had misinterpreted their nature, unable to discern their true form. It was Huygens who solved the mystery. With his superior lenses, he discerned that Saturn was surrounded by a thin, flat ring detached from the planet itself. He correctly hypothesized that the ring was composed of countless small particles orbiting the planet in unison. His insight was centuries ahead of its time, as it would not be confirmed until space probes visited Saturn in the modern era. Yet Huygens was not merely an astronomer, he had an insatiable curiosity for the nature of light, motion, and time. His work on wave theory would lay the foundation for modern optics. He proposed that light did not travel as a series of tiny particles, as many had believed, but rather as a wave moving through space, much like ripples in water. This radical idea would later influence the fields of physics and engineering, forming the basis for our understanding of diffraction and refraction. His inquiries into timekeeping also left a lasting legacy. Realizing that accurate time measurement was crucial for navigation and astronomy, Huygens designed the first pendulum clock in 1656. His invention dramatically improved timekeeping, increasing precision far beyond what had been possible before. The pendulum clock became the standard for centuries, regulating daily life, scientific observations, and maritime exploration. Despite his many successes, Huygens' life was not without hardship. The political and religious turbulence of the time forced him to move frequently, spending much of his later life in Paris under the patronage of King Louis XIV. There he continued his studies, writing Cosmo, a speculative work in which he pondered the possibility of life on other planets. In an era where such ideas were considered bold, Huygens dared to dream beyond Earth, wondering whether Titan, Mars, or Venus might harbor beings unlike ourselves. As his health declined, Huygens retreated from public life. Yet, even in his final years, he remained dedicated to understanding the natural world. He passed away in 1695, but his work endured, influencing generations of scientists who followed. Christian Huygens' contributions to astronomy, physics, and mathematics cannot be overstated. He unveiled the secrets of Saturn, shaped our understanding of light, and revolutionized timekeeping. His mind was a bridge between the past and the future, connecting the wonders of the universe with the meticulous precision of science. Tonight, as you gaze at the stars, think of Christian Huygens, the man who first saw Titan, who unraveled the beauty of Saturn's rings, who dared to envision worlds beyond our own. He taught us that the universe is not merely to be observed, but to be understood. So sleep well, dear dreamer, and know that like Huygens, you too can look beyond the known, reaching for the unseen wonders of the cosmos. Hipparchus, the ancient astronomer who measured the stars. Over 2,000 years ago, beneath the clear skies of ancient Greece, a man looked up at the heavens with a mind that sought patterns in the stars. His name was Hipparchus. And though he lived in a time before telescopes, before advanced mathematics, and before modern science, his discoveries would shape the very foundations of astronomy. With only his eyes and an unyielding intellect, he became one of the greatest astronomers of antiquity, a man who measured the cosmos with remarkable precision. Born around 190 BCE in Nika, modern-day Turkey. Little is known about Hipparchus's early life, but history remembers his contributions, his meticulous observations, his mathematical genius, and his ability to turn the night sky into a map of knowledge. Unlike many ancient scholars who often mixed science with mythology, Hipparchus sought logic, measurement, and proof. He is most renowned for his stellar catalogue, an extraordinary feat for its time. Before Hipparchus, the stars were seen as distant, unmoving points of light, unchanging and eternal. But he observed something different. He noticed that some stars did not stay in fixed positions, but shifted ever so slightly over time. To document these changes, he created the first known star catalogue, meticulously charting over 850 stars and ranking them by brightness, an early precursor to modern magnitude systems still used today. But Hipparchus's most astonishing discovery came when he compared his own stellar observations with those made centuries earlier. He realized that the stars were shifting not because they themselves were moving, but because the Earth itself was changing its orientation in space. He had discovered the precession of the equinoxes, a slow, cyclical wobble in Earth's axial tilt, which affects the position of the celestial poles over millennia. This revelation was groundbreaking, showing that the heavens were not immutable as once believed, but part of a dynamic, shifting universe. Yet Hipparchus did not stop there. He sought to quantify the cosmos with unparalleled precision. He devised one of the earliest accurate models of the motion of the moon and the sun, refining the length of the year with remarkable accuracy. His solar observations helped him improve upon previous calendar systems, making them far more reliable for agricultural and civic purposes. His work was so precise that his estimates of the length of a year were only off by minutes compared to modern calculations. One of his greatest mathematical achievements was his development of trigonometry, a tool that would become essential for astronomy, navigation, and engineering. Hipparchus compiled one of the first known trigonometric tables, allowing for the calculation of angles and distances in the sky with unprecedented accuracy. His innovations in spherical geometry would later be used by explorers and astronomers alike, forming the backbone of celestial navigation for centuries. But despite his brilliance, much of Hipparchus's work was lost to time. Unlike other Greek scholars, he did not write philosophical treatises or grand literary works. His knowledge was passed down through fragments and references from later scholars, most notably Ptolemy, who praised Hipparchus's discoveries and incorporated them into his own astronomical models. Because of this, Hipparchus's legacy endured even as history faded around him. Today, his name is honored in the stars. The Hipparcos satellite, launched by the European Space Agency in 1989, was named in his honor. This space telescope carried out one of the most precise astrometric surveys in history, mapping over 118,000 stars with an accuracy Hipparchus himself could only dream of. It was a fitting tribute to the man who first sought to measure the heavens with scientific precision. As you look up at the night sky tonight, remember Hipparchus, the ancient astronomer, who, without modern technology, charted the stars, uncovered the secrets of Earth's motion, and laid the groundwork for the science of the cosmos. He proved that knowledge was not limited by time, tools, or technology, but by the will to seek, to question, and to understand. So sleep well, dear dreamer, and know that even in the quiet vastness of the night, the spirit of discovery continues to shine, just as it did for Hipparchus over 2,000 years ago. Harlow Shapley, the astronomer who measured the Milky Way. On a crisp autumn night in 1918, an astronomer sat in quiet contemplation, staring into the vast night sky. His name was Harlow Shapley, and he was about to change humanity's understanding of our place in the cosmos. Through the careful study of globular clusters, ancient star groups that drifted at the edge of the Milky Way, he would reveal that our galaxy was far larger than anyone had ever imagined, and that our sun was not at its center, but on its outskirts. Born in 1885 in a small town in Missouri, Shapley's path to astronomy was anything but ordinary. He first dreamed of becoming a journalist, but fate had other plans. A mistake on his university application placed him in an astronomy course instead of a journalism program. It was a twist of fate that would steer him toward the stars, and he soon found himself captivated by the mysteries of the cosmos. He pursued his passion at Princeton University, where he studied under Henry Norris Russell, one of the leading astronomers of the time. At Princeton, he honed his skills in stellar astronomy and learned the power of observation and calculation. But it wasn't until he joined the Mount Wilson Observatory in California that his name would become synonymous with one of the greatest astronomical discoveries of the 20th century. Shapley was particularly fascinated by globular clusters, dense collections of stars found in the halo of the Milky Way. Using the newly developed Cepheid variable star method pioneered by Henrietta Swan-Leavitt, he was able to determine the distances to these clusters. He meticulously measured how their stars pulsed in brightness and used these observations to calculate their true distances. What he found was astonishing. These clusters were not randomly scattered, but formed a vast structured pattern around a central point in space. For centuries, astronomers had assumed that the Sun was the heart of the universe. But Shapley's data told a different story. He discovered that the Milky Way was vastly larger than previously believed, stretching over 100,000 light-years in diameter, and that the Sun was located far from its center, nestled in one of its spiral arms. This revelation shattered the long-held assumption of an Earth, or Sun-entered cosmos. Our solar system was not in the middle of anything. We were on the edge of something immense. His work ignited fierce debates. Many astronomers were reluctant to accept his findings as they challenged centuries of conventional wisdom. But as more observations confirmed his conclusions, the Shapley-Curtis debate of 1920, one of the most famous discussions in astronomical history, paved the way for the acceptance of a vast and structured universe. Shapley, though incorrect about some details, had fundamentally reshaped our understanding of the Milky Way. His contributions did not end there. As director of the Harvard College Observatory, Shapley led the charge in supporting women in astronomy, hiring and promoting some of the most brilliant female astronomers of the time, continuing a legacy started by his predecessors. He also played a crucial role in the discovery of dwarf galaxies, recognizing that the Milky Way was part of a much larger cosmic landscape. Shapley was also a firm believer in the connection between science and society. He was an advocate for scientific literacy, pushing for greater public understanding of astronomy. He believed that the knowledge of the cosmos had profound implications for humanity, shaping our perspective on existence itself. Even as his career progressed, his fascination with the grand scale of the universe never wavered. He saw galaxies not as isolated islands in space, but as part of a vast, interconnected web, though he did not fully grasp the implications of the expanding universe. This would come later through the work of Edwin Hubble. His studies of galaxies and their distributions laid crucial groundwork for modern cosmology. Harlow Shapley passed away in 1972, but his legacy endures. His work taught us that our home, the Milky Way, was far grander than we ever imagined, and that we are merely small travelers in an immense galactic sea. Tonight, as you look up at the sky, remember Harlow Shapley, the man who measured the Milky Way and found that we are not at its heart, but merely a part of its story. His discoveries remind us of our place in the cosmos, not as rulers of the universe, but as humble explorers of its wonders. So sleep well, dear dreamer, and know that even on the edge of a galaxy, the journey of discovery never ends. Carl Shawn, the poet of the cosmos. In the year 1934, in the bustling borough of Brooklyn, New York, a child was born into a world filled with wonder and possibility. His name was Carl Shawn, and though the earth was his birthplace, his heart belonged to the stars. He would grow to become not just a scientist, but a storyteller, a man whose voice and words would inspire generations to look up and dream of the vast cosmos. From an early age, Carl was captivated by the universe. As a young boy, he visited the 1939 New York World's Fair, where he marveled at visions of the future, space travel, interplanetary exploration, and the boundless possibilities of science. It was during these formative years that he first encountered the breathtaking idea that the sun was just another star, that there were countless suns beyond our own, each potentially with planets of their own. The realization left him aruck and filled him with an unquenchable thirst for knowledge. Sean pursued his passion with relentless determination. He attended the University of Chicago, where he studied physics and astronomy. His mind was an insatiable engine of curiosity, questioning everything, seeking deeper truths. Under the guidance of great mentors, he became an expert in planetary science, developing a keen interest in the atmospheres of other worlds, particularly Venus, Mars, and Jupiter. His early work was groundbreaking. He proposed that the scorching heat of Venus was due to a runaway greenhouse effect, an insight that would later serve as a warning for Earth's own climate. He theorized that Titan, Saturn's largest moon, might contain vast lakes of liquid methane. He played a role in designing the famous Mariner, Voyager, and Pioneer missions, ensuring that humanity would not only explore the planets of our solar system, but send messages into the vast unknown. But Carl Schorn was not content to remain in the quiet halls of academia. He believed that science was not merely the domain of scholars, it belonged to everyone. He had a rare gift. He could make the cosmos feel intimate, personal. He had a way of taking the most complex scientific ideas and translating them into poetry, turning cold data into dreams. This gift found its ultimate expression in Cosmos, a personal voyage, a television series that would change the world. First aired in 1980, Cosmos took viewers on a journey through time and space, exploring the origins of life, the evolution of galaxies, and the nature of the universe itself. Sean, with his gentle voice and boundless enthusiasm, guided millions through the story of the cosmos, showing them that science was not merely about numbers and equations, it was about wonder, about understanding our place in the vast expanse. His most famous phrase, "We are made of star stuff," encapsulated his philosophy. He saw the universe not as something distant and separate, but as something deeply connected to us all. Every atom in our bodies, every molecule that forms the world around us was forged in the heart of ancient stars. We were not just observers of the cosmos, we were part of it, inseparable from its story. Sean's work extended beyond television. He was a prolific writer, authoring books like The Dragons of Eden, Pale Blue Dot, and Contact. Each work carried a singular message. Science is a candle in the dark, illuminating the mysteries of existence. His book, Contact, was later adapted into a film presenting his vision of first contact with extraterrestrial intelligence. One of Sean's most profound contributions was his role in the Voyager missions. He was instrumental in creating the Golden Record, a message sent aboard Voyager 1 and Voyager 2 containing music, sounds, and images of Earth, a cosmic time capsule meant for any extraterrestrial intelligence that might one day find it. It was a testament to his belief that humanity should reach beyond itself, that even in the vast darkness of space, we should send messages of hope and curiosity. But Sean was more than just a dreamer. He was also a fierce advocate for reason and critical thinking. He fought against pseudoscience and superstition, believing that skepticism was essential in a world increasingly clouded by misinformation. Clouded by misinformation. His book, The Demon-Haunted World, championed the importance of the scientific method, warning of the dangers of abandoning rational inquiry. Yet despite his deep scientific knowledge, Sean never lost his sense of humility. He often spoke of the pale blue dot, an image of Earth taken from billions of miles away by Voyager 1. In that tiny speck floating in the vast darkness of space, he saw the sum of human history. All our triumphs and failures, our wars and peace, our loves and losses. He reminded us that in the grand scheme of the universe we are small, yet capable of great things. Carl Schorn's impact did not fade with his passing in 1996. His ideas, his words, his voice continue to inspire dreamers, scientists, and explorers. His influence can be seen in the work of modern scientists, in the ongoing search for extraterrestrial life, in the renewed interest in space exploration, and in every child who looks up at the night sky with wonder. Tonight, as you close your eyes and drift into dreams, imagine Carl Schorn's voice whispering through the cosmos. Imagine yourself floating among the stars, exploring distant worlds, seeing the universe as he saw it, filled with beauty, with mystery, with boundless possibility. So sleep well, dear dreamer, and remember, we are all made of star stuff.